So we're going to first look at why do we BIM? Why are we even using this? You know, we were doing just fine 20 years ago. Why did this come up? The history of BIM, like how all these technologies came to be, and what has been the process of the AEC industry adapting these technologies, and how are we doing currently? Like, what are our current struggles? What are we using these technologies for? And all the challenges that come with the basically current situation of the industry. And then we're going to look into the upcoming trends and the future. So my name is Yigit Karanfil. I'm a design technology manager at HOK. If you want to contact me later, just maybe add me on LinkedIn or maybe give me your card, because I don't have cards yet. I've been there only 5 weeks. I've been working as a multidisciplinary BIM expert for several years before I joined HOK. And I've been an active member of CAN-BIM Designers Steering Committee over the last like 4 years, I think. So our first topic, by the way, if you have any questions during the presentation, just ask them. There's isn't a huge crowd here, so it's totally fine. So the first question is like, why do we BIM? Why are we even doing this? So historically, what we've done is we used to do hand drafting. So the whole logic behind this process is we use some hand drafting tools like T-squares and pens, pencils, to create a set of drawings that tell the contractor and like everyone involved what kind of building we're doing, what do they need to follow to get this concept into a reality. So it's a set of instructions that you follow, and as the end result, you get to produce a physical building. So you just basically, when you're drawing lines are meant to present something. They're kind of abstract representations of the physical building. Then we had CAD technology, computer-assisted drafting, or drawing and drafting, sometimes mentioned as. This process is exactly the same as what we did before. Actually, it's just to create that drawing set, we're just using computers. But at the end of the day, there's nothing different about what we used to do to create a drawing set and get it constructed, because it's all just lines and they don't carry any data necessarily other than the geometry itself. So it stayed pretty much the same. It was only a matter of just changing the tools that we use to produce that drawing set. Then building information modeling came along, and it all got extremely confusing, because you produce a model which can definitely produce that drawing set for you, but it has so many other uses. So on the design side, so this gets into the whole life cycle of the building, design, build, kind of operations, and then of course you keep repeating that process until it gets demolished. So on the design side, we are able to now do things like programming and verification. We can analyze our model for certain different things. AR, VR is coming in, becoming a really kind of big thing right now in the design world. We, of course, because we're producing a 3D model, we're able to visualize this and enter all sorts of data. Then that can then feed the other aspects in the physical building and affect the operations and actually the building as well. And also it gives us better collaboration opportunities as well. On the building side, of course, like we're still kind of like following the designer's instructions and kind of getting this built. But we're able to now do like things like site verification. Like, I mean, we're able to do either maybe laser scanning to see if things are getting built right, or actually calibrate devices to pinpoint exactly where things should be installed in the real world. We can do site planning. There can be some better coordination going on before it goes to construction, and we can even create fabrication models where everything is pre-cut and assembled quickly on site. And of course, there will be some more data entry that is related to the construction site. That's mainly because of how the contracts work, and we will get into that. And then it goes into the life cycle and operations, where now you don't only receive just a building and the drawings that are like a reference for the building, but you can also get like COBie output, which is a spreadsheet with all your maintainable assets that gives you some idea as in which item is where and what is their warranty period. Like all that information can be just given to you by the designer and builder right off the bat when the building is commissioned. And then you can tie your building information model to your building automation system and the facility management systems, and getting a record model so that can interact with your, that can possibly interact with your facility management, and even all the way down to your IoT devices that are, tracking things in the building. And of course, in addition to all these, you still get the building itself. Now, the problem is, up until very recently, I mean, this is just kind of slowly changing, but this has been more or less how we actually get this done. So just because there's all these possibilities doesn't mean that, we're completely utilizing them to their maximum extent. Usually we, on the design side, use this for, all the things that benefit the designers, they tend to use those, the visualization, creation of drawing sets, like everything is more coordinated, and there are less rooms for mistake. This is a bit in quotes maybe. We're going to, again, get into this later. So all these like visualization options they'll gladly use, but then it's just going to go to, basically it's going to go to construction pretty much with a similar drawing set. And then the builder themselves might actually kind of utilize the model or not. Sometimes you will see that designer will be reluctant to hand out the model because of legal concerns maybe. That's happening less and less, thankfully. And then a lot of times the interaction with the client is either they are completely unaware of BIM, or they come to us and say, oh, can you hand us a BIM model? And we say, of course, sure. Yeah, we'll hand you a BIM model. And at the end of the job, we just package the model and send it to them. And they have no idea what to do with it, and they don't use it most of the time. There are, of course, exceptions. Then basically the model data doesn't really affect this whole building and life cycle process all too much. We are seeing some changes in this whole kind of, how would you call it? Maybe the zeitgeist of the construction industry. So how did we get here? Like, why did we have a bit of a hard time maybe? Like historically, let's get into like how we manage this. So the industry is obviously still adopting the BIM workflows, and there's a bit of a lack of established processes and standards. As Carl was mentioning too, it's just like everybody has their own way of working, and that doesn't always necessarily come together very well. And I will also argue that there is a bit of a conflict of interest between parties because of how things are contracted. And clients have been taking notice and getting to understand how these technologies work and how they can make use of it, and like just how they can save a lot of money actually during the operations of the building. But this all comes down to BIM basically being a new technology. Is it though? So I have a question for you. When do you think the first BIM authoring software was released? So just take a look at the options. I'm going to ask everyone to raise their hands, as in like when do you think it has been released? Who thinks it's 2002? No one? Okay. Who thinks it's 1987? One person? Two? Okay. Who thinks it's 1995? Okay. And who thinks it's 2000? Okay. So it's 1987. So Yeah, it's not that old. So, sorry, it's not that new at all. Like, it's 32 years now. Yikes. So, and just so you know, it's ArchiCAD actually, unlike what anyone else might want you to think. ArchiCAD by Graphisoft is considered the first BIM software. I don't think the term was coined. There's a link to an article there. You can check that. I don't think the term BIM was coined right there and then, but it is considered to be the first example. And if we look at this graph, so this is from the NBS National BIM report. Just taking the British stuff, of course, because they seem to be a bit more ahead in means of implementing and mandating it. So since starting 2011, of course, there's some history before this, but starting 2011, you can see the trend mostly going up. And then in 2019, they just published this, I guess because it didn't look as impressive anymore. So they just kind of put this there because there's like it just kind of came to a bit of a halt. I think it's going to be a bit slower maybe moving forward. But we see this taking, so basically we see BIM becoming the norm and really, you know, being used by more people only starting 2011 and after, basically. So the question is, like, what obstacles caused us to take so long to adapt? It's just this thing, like, there were obviously companies using this in maybe early 2000s, but presumably it's not much. So, I mean, why are we so bad at this? But before we ask that, I'll just say not so fast maybe. Like, you know, just because something has been invented and it is there, it doesn't mean it's necessarily feasible to apply that to the current world situation. So first of all is the technological obstacles. We didn't always have the processing power that we have today. And just because we had a BIM software in 1987 doesn't mean like you can take that and just build an airport with it, right? So if you think about Gorilla Glass, right? This thing was invented in 1960s. Today, it's in everyone's pockets, but for 40 years, like, nobody did anything with it, right? It was invented back in 60s, and it just kind of, it was just sitting there until Apple went to Corning and said, look, we need something really durable for devices with huge screens people carry in their pockets, which really wasn't a thing back then. So basically, that technology found its use in early 2000s. And likewise, if you look at this, this is 42 years of microprocessor trend data. So over here, you see the transistor counts, which has been going up constantly, but that is kind of coming to a halt, and the single thread performance is also coming to a halt, which is unfortunately mostly what we rely on. Basically, it has been growing exponentially. So if you look at like 1970 to the 1980s, like it's like basically it grew 10 times. And from 1990 to like 2010, if you look at this, this is about like 1,000 times basically. So it's been growing very fast. So I feel like somewhere along the lines, like somewhere here, I think BIM became feasible. So now like we can actually digitize our buildings and start building them in the virtual environment before we go to construction. And also another aspect of this is the cost. Just imagine like how much computers costed in the 1980s. So this is the consumer price index. This is only from 1997, unfortunately, because that's the largest data set I could find. Then just kind of threw it to Power BI and just kind of got this chart. So this is the computer consumer index for computer and peripheral prices. And also this is for computer software and accessories. Although I'm not sure if this really applies to us, this kind of software pricing thing, because we're facing much more different things today, I think, with software, which we will get into pretty soon. So with the hardware prices consistently going down and the processing power just exponentially increasing, we came to a point where we can actually use it. I'm not going to say we're doing great. We're still, I think, being very slow, like adapting to this whole thing. But there were, I think, good reasons, at least up until some point, why this wasn't very feasible to take this proof of concept and apply it to our actual buildings. So about the software side of this whole thing, so I don't want to name any names, so I blurred these out. So you definitely can't tell who these people are. But we're living in an age of software monopolies, essentially. So there are several reasons for these. Mainly, we want to be able to work with each other, to collaborate with each other, and interoperability is not necessarily there. So we don't want to kind of, so everybody wants to be using what everybody else is using. And a lot of these companies seem to have their own kind of small niches, and they're not really competing with each other much. And the result of this is, like, whenever there is no competition, the consumer, it's just bad for the consumer. And I don't think we get the best products we possibly could as a result of this. And just, again, the lack of interoperability just kind of adds fuel to the fire, where it's just, it makes it really, really tough to just say, okay, I'm just going to use this other software I like moving forward. And of course, one of the biggest challenges we have is cultural. So how many people in architecture here? Okay. How many of you have a drawer or a box that's like full of stuff like this? Just, just pens, pencils, paints. I know I do. I mean, I'm in design technology I've been in design technology for a long while, but I just still can't throw these markers I had back in school, basically. They still work fine too. I'm kind of impressed. But we've been a relatively conservative industry, and even when just kind of moving to CAD, we struggled a bit. I should know because one of my instructors back in the university was still making us draw details from 1960s by hand. So that gives you a clue. So, most people are still used to working with 2D sets. I would say architects are generally doing better in this area, but especially engineering technicians I've seen a lot of times have a really hard time adapting to using a 3D model, because they've always been kind of drawing these schematic single lines for piping, or they don't even dimension the drawing. It's not a super accurate location. So it's always been traditionally very very schematic in nature, what they produce, and then it's just we're gonna resolve it on site. Basically, has been the general response as in how this is going to be built. I remember a structural engineer actually when he was a bit fresh, and I told him yeah, MEP doesn't dimension their drawings, and he was horrified. I'm like, oh, you summer child, just you're about to face the winter. So. So, and of course, they're facing other issues where, build these drawing sets that look nice in 1 to 100, but also give me the exact accurate locations of everything, which, of course, when you place 2 quarter-inch pipes next to each other in a ceiling space, it's pretty easy to place them physically. But if you draw 2 thick lines very close to each other, it can't be readable. So they're also facing problems like that, to just cut them some slack. And of course, BIM requires a very different thought process. It basically requires you to plan very well, and also everything you enter is information, and the accuracy of that information. And if you whether you're cutting corners or not, just impacts your model quality quite a bit, which again, we're going to get into a bit more later. And a lot of times BIM is seen as a documentation tool and not intended for design, basically. So that kind of pushes people back to using more traditional or different tools, or tools that don't necessarily contain any information like SketchUp or something to design, basically. And of course, we have educational challenges. This is both coming from the schools themselves, like all the way starting from, so almost everyone in the industry has some sort of college or university education. But in school, you don't necessarily learn BIM or BIM software, or even just the basic concept. I was lucky enough to have learned them, actually. This was like, well, more than 10 years ago now, but I actually had an instructor that would teach me all these things. But a lot of colleges and universities still are kind of adapting their programs. Right now, there are some BIM management programs. They are kind of becoming popular. I think Algonquin and George Brown have these programs. But it's not, for instance, well, I don't want to be kind of, I don't want to say bad things about engineers. I'm just kind of stating what it is here. But if you think about it, a mechanical or electrical engineer won't even necessarily work in the buildings industry. So it could be maybe an elective for them. But I mean, if they're going to go build rockets, there's no sense in them kind of learning any of this. So there are maybe some justifiable parts to that as well. And of course, with all these struggles, we're also trying to re-educate the existing workforce to, because we already have a lot of people like who are designers, who are architects, engineers, and we're trying to get them to learn BIM and kind of work with a completely different mentality. All right, so, and in means of the education, basically, I feel like there's a misconception as in like, if you just get a BIM manager, like you're just kind of good to go. And basically you can just kind of, say like, okay, you just go and do all these stuff. Like you got to teach stuff, and like you can review our contracts. Like, I mean, if you're lucky, like the contracts actually come to you and somebody checks them before they're signed for the technological requirements. Model management, data management, modeling, all the infrastructure, research development, wizardry. So anything is like on the BIM manager. And this, of course, doesn't work very well because there are risks involved, and there are other skills that have to be applied by other people in a company setting. This is very simplified, by the way. There can be like multiple layers and such, just for the sake of demonstration. And this is probably how it should work. First of all, like drafter as a profession is kind of dying away mostly, and we have modelers now, or designers, and they need to know how a building comes together and how design works a bit better than the said drafters, basically. So they need to be able to maybe manage the model, and they need to be able to collaborate with others, and basically like, there are more skills required here. And on the level of the project manager or project architect, maybe engineer or a principal as well, there are some things required. So, if you are a principal in a design company, for instance, and you look at a contract and there's something you don't understand, you either should be educated enough to understand the technological requirements the client is asking from you, or you should be able to at least go to your BIM manager or like whoever in-house you have as an expert in this field, and just kind of ask them like what this actually means and what kind of risk does it pose for us. And on the level of the project manager, now we're doing things like, we are maybe using systems where the building data is stored externally and tied back to our BIM model. Then while the project manager or the project architect is the person who establishes that data in the first place. I mean, even without databases, spreadsheets, and whatever, we're already doing this. So what we're doing is basically, if we're modeling this classroom, we're saying, okay, there's going to be 20 desks, maybe 60 chairs, and so on. So there are requirements here. And instead of doing that manually, you can get the computer to do that, but then your person overseeing the project really needs to be able to contribute to those and maybe go in and check themselves. And this is a kind of skills matrix from the AEC's BIM protocol. It kind of gives a kind of good breakdown for, this is probably like a larger company in this case, because there's a BIM manager and the coordinator in between, and then you have the modeler. So the skill set kind of spreads out, and of course there are just overlaps every once in a while. One of the big challenges also has been, I think, economical, because I mean, this whole thing has not been cheap. The costs include anything from training, just kind of the hours you will spend, or the software you will buy for the training of your staff, to hiring costs. It's just you now need maybe people who have a different skill set, or people in new positions like BIM managers or coordinators. Developing your standards, so you set up your CAD standards 20 years ago. Now you have to kind of ditch them and kind of build your BIM standards. Workflows, because again, there is no standard way of working on a lot of things, and there's been a real shortage of resources. Like, for instance, if you were looking for BIM models, you would have to really just kind of do it yourself, even like 5-6 years ago. Now a lot of the manufacturers are kind of chipping in, and they're also contributing to this as well. So it's getting better, but still you need to invest a lot of your time and money. And software costs, of course, these unnamed guys are they just kind of keep charging us money every month, because you can't buy software these days. So a lot of things are also moving to the cloud, but even if they don't, there is almost no software today you can go out and just kind of outright buy, and it's going to be yours for the next, I don't know, however many years you want. You're essentially renting the software by the subscription models. And of course, there are legal concerns. So we had the keynote speech this morning, which I think just kind of gave us a good oversight of the legal scene, especially in Canada. So there hasn't been any huge disputes about like models. So we don't have evidence to suggest that handing a BIM model to another entity puts you under a lot of risk. We're still being cautious, of course. There's disclaimers flying around all the time whenever you're exchanging models. But there are still just kind of concerns, and you might have cases where the consultant just flat out just refuses to give you the model, saying like, this is not our deliverable. And even though it will be just kind of zipping a file and sending to you, we're not going to do that. So I think another aspect of this is BIM is more geared towards a collaborative working environment, but because something like with AutoCAD or like with hand drafting, basically, it's just if somebody did things in a way that doesn't necessarily benefit you, it's maybe easier to mitigate those things. But basically, because of the hiring structure, and because still the design bid build is still the most popular method of building things, the different parties simply don't have an interest in what happens to the other when their model quality is not up to scratch, for instance, or maybe something minor that would make things better for another. So an architect doesn't necessarily have to comply with a request from an engineer or from a contractor, basically. And basically, the way we work is we charge for however many hours we're going to work on a project. And basically, if something is going to cause a consultant time, they're not going to do that for free. And that's very understandable, but it's just the nature of the contracts, I think, get in the way of collaboration a lot of times. If you want to do a bit more reading on the subject, there is a document on CanBIM website called History and Future of BIM for MEP in Canada. So this kind of gets into a lot of the subjects that we talked about. This was 2017 when so we had a roundtable back in Toronto in 2017, and this was about MEP. The people from different aspects of the industry, like subcontractors, contractors, designers, kind of came together to kind of discuss these issues. But it does apply for the rest of the industry for the most part, and holds up pretty well, because I've had cases where I've authored articles and such, and 1 year later they're completely just outdated and they're not maybe valid anymore. Not the case for this one, thankfully. So you can check this. Okay, so I'll move to what we're doing today and what is possible to do with BIM with the tools and resources we have in 2019, basically. Any questions? Okay, so today's possibilities. So, of course, the number one reason we use BIM for is the efficiency and accuracy. Although this kind of comes with an asterisk, because you really need to have your people trained and they need to be doing things right to get this at the end of the day. But the whole idea is, if I place a door, it's going to look like the same door in 3D, in section, in elevation, and in the schedule, it will have the same information, basically. So I don't need to worry about, like, oh, I moved this door, like I need to move this in the section or elevation as well. And who knows in how many of those it appears, actually. So it just kind of relieves us from thinking about that when we do things right. So another possibility today is automation. Today we have a lot of good automation tools that can actually be scheduled and run completely remotely on a maybe different desktop, because one of the biggest problems has been just kind of, if you're exporting a model, just printing PDFs or anything along the lines, you usually have a architect or engineer just kind of looking at their screen for like 2-3 hours. That's not a very productive time, so we're able to actually take care of a lot of those. And of course, like custom scripting has taken off quite well. A lot of software right now we use have their own APIs, so we can kind of customize them to do things. So these are just some examples of like what you could be doing with automation. Of course, the list can just kind of go on depending on what you're willing to invest in or what you're willing to develop, basically. And of course, coordination is a big item. Besides the clash detection software, so just to keep in mind, like coordination is not clash detection. Like clash detection is coordination, but coordination is a broader term. If I had a column in front of that door, that's not a clash, but it's also not great design. So that needs to be coordinated. And we have software that allows us to do this a bit better, I think. The market is completely saturated with the software where you can kind of track your model and find exactly where the issues are. I've especially seen where if there is a distance between the teams, I mean like physical distance, basically, literally somebody could be working at the other edge of the world and you're able to efficiently convey an issue that needs to be resolved to them. So, and of course, the clash detection itself is this kind of semi-automated process where it will tell you if an object is running through another object, which can take a long time to detect by just kind of looking at your screen. But you got to be granular and careful, which is the topic of a whole another presentation I did last month. Okay, so planning and verification. So this is, I think, one of the really good quality control tools that we have in our disposal, and unfortunately it's being a bit underutilized right now. So you could be using anything like either Drawfus or Codebook, or even a simple Excel spreadsheet to enter your data and then compare this with your model. So when I just say, okay, say fancy things like data entry and such, I'm just talking about like just enter your room names, numbers, and like the areas that they're required. Then you can just kind of compare that with your model, the information in your model. It can be as simple as that, or it could be as sophisticated as detecting each and every item that is supposed to be in your model, like driven by a full-blown database system like Drawfus or Codebook. And planning and verification. So we are able to verify site conditions in different phases of the construction. So pre-construction, or basically pre-design, you could be scanning a space to you could scan a space to understand how not accurately it's been built in the first place. So you can kind of capture the real world conditions and then base your design on top of that. Besides this, also there is actually specialized software that will check your kind of tolerances when constructing things. So let's say if you put up the kind of structural systems, then you can kind of compare that to your model. So contractors do this in different stages of construction to from, let's say, maybe structural, the establishment of structural to the end of construction, to see how they're progressing and how accurate they are actually being with the implementation of the design. And visualization is, of course, another really big item right now. There's been, I think, recently a shift in the whole visualization landscape. So BIM models being generally 3D, they don't have to be 3D, by the way, a lot of times. It's just you can still enter information to 2D items as well. It doesn't have to be perfect, but of course, like modeling things in 3D saves you the trouble of exporting this somewhere else and kind of maybe tweaking another software. You can just kind of natively use something like Revit or ArchiCAD to render something pretty quickly. But up until recently, the high-end rendering was just kind of, I'm going to throw this to like either Mental Ray or V-Ray and render it for like 5 hours to make something look decent. Right now, we have very powerful graphics cards, basically. The technology with those came a long way. And we have actually the software to use with them, such as like these, like Enscape, Lumion, or Twinmotion. These are called the game engine based rendering systems. Twinmotion is literally using a game engine, which is the Unreal Engine. So basically, these utilize your graphics cards and technologies like ray tracing to visualize your model very, very quickly. So you're able to get your images in a matter of seconds instead of hours, basically. So for high-end rendering, there's still like rendering engines are still being used, but these can give you like really good results. And it's one of the reasons I have a laptop like this, which is like, this is a gaming laptop actually that has a $1,000 graphics card in it, which would make no sense for working in Revit, but it works great with tools like these. And of course, one of the advantages that these tools have is you can actually just kind of get into the VR environment with a push of a button pretty much. And you can either use this for client engagements or just checking the model yourself, basically. So I've seen a lot of designers kind of looking at their own design and like, oh, okay, the ceiling actually, I thought it was going to be too low, but this doesn't look too bad, because they get a sense of the scale. Like designers are good at visualizing something, but it still isn't like, putting on a set of goggles and seeing it for yourself. It's a different field. And analysis, this is a very broad one. I'm going to kind of gloss over it. But basically, these 3D information models we create can, of course, be used to do many kinds of analysis. These include, but are not limited to, sun studies, artificial lighting, structural pedestrian simulations, and energy modeling. So what you see here is actually, I think this is Elam Tools. This is a lighting analysis. So it just kind of calculates how much light is falling on each spot based on the lights inside the model. So you can, I mean, software like this existed a long time ago, but what I've seen before was like people would just kind of export these to a completely different software and set all the parameters there again, which, I mean, we already have this in our building information model. So we can just kind of use that to quickly understand how our lighting system is going to work. And one thing is, maybe I should mention, software like SAP 2000, for instance, that does the kind of structural analysis, or like like ETABS or Robot, basically. Those are also BIM tools. Now, there are sometimes difficulties with the interoperability, as usual. It means of like bringing them back to other software, or you don't get to produce a drawing set from them, but you are still modeling an intelligent building, basically. You're just entering all these data about the loads that are going to be on your columns, beams, and you're defining items, and you're defining their sections. So it is actually definitely BIM software, at least in my mind. And okay. Another thing, so this is mostly on the contractor side, is so this is a snip from Synchro's own website. So these elements that we've created, you are able to use a construction timeline, which is like, you would of course do like scheduling for construction, right? And you can now associate those with the building elements in your model and either prepare animations like this, or basically just kind of see visually how it will come together. So now everything in your schedule, or most things in your schedule at least, will be referring to a actual building element. So it's relatively easy to associate them using the right software. And of course, we're getting to the kind of client side here with asset management, which is, I think, where we will see the most changes in the next maybe 5-10 years, and which is going to impact the industry the most, probably. So COBie is a open, it's an open format for building data. And to really simplify this, it's a spreadsheet. Like, it's literally a spreadsheet you produce from your model. And it contains usually data like, so basically you're looking at trackable assets. Let's say you have an air handling unit. What is the number of that air handling unit, which room it is in, which floor it is at? So that is about what the mechanical engineer would give in means of information. And then the contractor just comes in, and they could also provide information for like, who's the manufacturer, because there's this whole thing where they can actually install something else that performs the same. That's always fun. So there's no point in designer actually kind of entering that data. So they can also enter the manufacturer, warranty data, who do you need to call if this breaks down, and all that. And then this information can be just pushed down to your asset management software. But another alternative is, so instead of pushing this to a spreadsheet and then having your software, asset management software, import that, you could actually use a BIM-based asset management software directly. So the way this works is the data you need to absorb in the asset management system is already in your model. So instead of doing an export, you push the model to the system, which there are like a couple of examples I've given here, like Willow, BIM 360 Ops, and Ecodomus are some examples. So these can actually connect to, some of these can even operate your building automation system. So it will not only get your data and create a digital representation of it in the asset management software itself, it will also control it basically, and it will be able to maybe tell you, okay, you need to maintain this now, and it will show you the exact location where it is. And it can even go further to go down to IoT devices, such as, like, it doesn't always have to be like major equipment. It can come down to things like tracking a number of people passing through a certain hallway, doing heat maps, visualizations, data collections. I say like data is the new gold basically. Like we have a lot of it and it's all scattered, but data has time and again proven to be very valuable to track for pretty much any entity. So smart buildings are on the rise right now, and we have experiments in different scales kind of going on, and especially if you want to look at some of the more advanced works that was done with this, you can check, I think WeWork had a pretty good study with how they fitted all their spaces with IoT devices, and they were able to get some efficiencies by tracking some movements basically. Of course, there's a whole privacy issue side of these, just not getting into that for now. Okay, so these are what we're able to do now. We don't necessarily do all these for every project. As I mentioned, it's not all rainbows and unicorns, but these are being implemented today, like it's possible. But with these, of course, come some struggles. So what are we struggling with right now? Model quality is, I think, the number one challenge that the whole industry is facing. I have a very, how would I say? I have a very elaborate depiction of garbage in, garbage out here. So, so the idea is, if the data you feed to the model in the first place is not accurate, and people keep cutting corners, then remember this whole thing about like things being accurate and in their correct places and the data is correct? Well, it is not if people are not entering the right information, because at the end of the day, we're still relying on people on either on design or construction side, like whoever is building these models, we're relying on them to give us accurate data so we can do things with it afterwards. Because all these like different things we can do rely on them actually just kind of building an accurate model. And with all these like educational challenges also I've told about, and kind of re-educating the staff and being able to find the right staff, model quality is generally a bit of a problem. And I think the government and client interest is kind of, there's an increased interest for sure, but I think the real thing that's going to drive this industry and that's going to allow us to implement BIM and technology better is interest from the client. Because if there are inaccuracies and the model quality is not great, but at the end of the day, if the client is not too interested in this, they just want a building delivered, and maybe they don't understand what issues occur between the whole, what happens from start of the design to end of the construction, and how technology can solve them. If they have a disinterest, then I don't think we're going to easily just say, okay, let's just do this better. They have to be the one pushing us. At the end of the day, they're the ones who are paying us. So it's likely that their word will be taken a bit more seriously. And countries such as UK already have legislations in place to mandate BIM on certain buildings. I think all the government jobs are being done there now. There are advancements in Canada as well, of course. I'm going to get into them soon. But the whole regulation side, and also there's of course countries like Singapore where now they're doing e-permitting based on a BIM model, which is definitely like next level stuff. But we're not there yet, but I believe we will get there. Interoperability, as I mentioned in every opportunity I absolutely have, is a big problem. So each software has their strengths and weaknesses. So you don't want to use one software for the sake of just kind of, sticking with it. Of course, using too many software has its own problems, namely cost. But you really want to kind of take advantage of the strengths of software. The problem then is, like, let's say you use one software for documentation and another for your analysis. There are a lot of inefficiencies when going from one to the other. And basically, the developers don't necessarily have a lot of incentive in giving you tools to have better interoperability. They want you to be they want you to be in their own ecosystem, right? They have a stake in making you use their software as much as possible. So they don't necessarily want you to go to use something else. And we're, at the end of the day, restricted to decisions, like whatever decisions they made when developing their software. And, like it's not, and maybe we will end up just kind of sitting down and developing our own software, which we are to some extent with some visual programming options we have, which again will be another slide here. So IFC and BCF are open standards. So IFC is for open source model format. Basically, BCF is for coordinating between different software. So it's strictly a collaboration format. It just records the place, comments, and a picture of your issues, basically. This actually works fairly well. But on the IFC side, I will say it's a great format for storing and reading the model, but it really doesn't give us a lot of room for using it for authoring. So if I'm just kind of creating a model and I'm, if you're bringing an IFC to a facility management software where it will mostly read the model, I think that's great. But if you're in a design environment or you're trying to create your documents for pre-manufactured maybe systems, it really doesn't do much for you, unfortunately. And of course, the lack of common standards is just causing a lot of inefficiencies between different entities, basically. So just unless it's planned very, very well at the beginning of the job, you almost always run into things where you have difficulties coordinating either with consultants, with contractors, subcontractors. Just keeps happening, and maybe Building Smart or Kanban will help us with some of these. We'll see. And with all these challenges, there are a couple of trends right now that are on the rise and that look pretty positive, and it looks like they're going to only grow from now. Government and client interest. So just bringing this up again because actually Carl mentioned already the Alberta infrastructure standards. So right now they're asking for a COBie delivery for all their buildings, and they have a pretty bricky digital project delivery documentation on their website. So everybody can just kind of go there and access those. It's quite the read. But it's pretty impressive, actually. They're just kind of looking for a they're looking for an IFC format delivery, just kind of because it's an open format. They don't want to really favor any one software company, basically, and just kind of looking to get some data from the building itself. And PSPC, right now, they don't have it public. I know they have a draft, but you can see, so this is from their kind of public website, basically. they are developing their BIM standards right now. So that means basically we're going to see some BIM requirements on the federal level pretty soon, because PSPC is a federal corporation. And artificial intelligence. Now, people really like throwing the word AI around, but I mean, if you think about what it is, it's a very complex thing to build, actually. So there are very limited applications of this right now. They seem to be working well. It's developing, but it all comes down to kind of the algorithms that you build. And of course, there is maybe machine learning applications that could be beneficial on the long run, but that really, I haven't seen that bleed much into the buildings industry yet, unfortunately. So just to give a few examples of what's going on with AI, Sherlock, one piece of software I saw some time ago back in Autodesk University, basically it tries to guess how it should group and manage clashes in a logical manner. So you do feed some of the information to it, saying like, I want to prioritize these items, or these items are related. Then basically, instead of, this is especially good for the construction phase, because they have much more small details like you see here, like all these hangers and such. So it's able to kind of group those together, saying like, look, actually there's like one conflict here. Because the clash detection software, they tend to just kind of give you everything, like every single, like, oh, this object's running into this is running into this. But like, if you think about it from a design perspective, like, I just need to maybe move one device from there and this problem will be solved. And that is what I want to see. I don't want to see 10 items for this single issue. Another interesting thing I've seen, this is recently actually, this was in Cannes, Montreal. This is called Indus AI. So this is a camera system essentially that identifies things like trucks, people, anything going on inside basically. And it can also detect safety violations. So not everybody's a big fan of this, as you can imagine. So if you're just walking around without your hard hat, it just kind of tags you immediately. Model to construction. So remember this whole thing where like we're still actually, we're doing our virtual building, but we're still going to, we're still creating a set of drawings and we're stamping those, and just then those are essentially the guide to produce the building. Now, how about we remove this whole create drawings part? Now, it kind of sounds like maybe years away, but I personally haven't worked on a project such as this, but there are examples of model being the delivery and you don't necessarily submit and stamp PDFs. The model is the instruction basically. So you go straight from your virtual representation to the real building itself.
So in something like that, you not already do page setup?
I'm assuming there would still be some like for kind of maybe kind of controlling and such, but it's not a deliverable. So you don't really deliver like hundreds of pages and stamp them. Like when you submit the model, they just kind of build from the model. The logistics of that, I'm not too familiar, but I know it is done. And cloud services are definitely on the rise. It's who was saying this? Like cloud is just someone else's computer, which is true, but it comes at a premium price basically, which is part of reason why software companies really like it. They can charge you a good premium for all this. But also, it's hard to deny that they give us a good environment to collaborate, and you know, the FTP upload downloads are becoming a thing of the past more and more. I mean, if the prices come down a bit, they might be. So the question is, what does this game have in common with future of architecture? This game's called Dead Cells. I actually ended up dropping it. It's a bit frustrating, but what I want to get attention to here is this game has randomly generated levels. So it has a set of rules where it will generate a different level for you every time you play. So every time you die, you just start from the beginning, and the map doesn't look like the last time. Like it's ever changing. So the question is, would we be able to generate an algorithm that we feed it some parameters, and as we change those parameters, it would just kind of give us different options? And the answer is yes. Like, we're doing this to some extent already. Generative design has been used for the last, like, I guess, like 10, 12 years. Like, that's when this is Grasshopper, basically. So we also have Dynamo as a tool. And this is basically from a different presentation we did with my good friend Tommy Weslinski from Dialogue. So this was a part of it, basically. So he's able to kind of draw certain elements and configure some of the parameters, saying, okay, now make this like 5 stories. Now twist this tower a bit, maybe. Or just, you're able to kind of manipulate the building design just by manipulating your code or the inputs. Now, of course, the biggest problem to this kind of workflow is the barrier to entry right now. So whether you're using something like Grasshopper or Dynamo, these are, at the end of the day, visual programming software. So you need to know programming, basically. And it's not what usually architects and or electrical or mechanical engineers want to do. They don't want to, like, very few of them will actually bother to learn coding to get into those systems. So what's going to happen here? Are we going to start teaching architects and engineers more programming, or is this going to become more mainstream, basically? Can I actually get a software where I get to do regenerative design, but maybe I don't need to know how to code for it? And one ambitious kind of startup for this, I just kind of happen to know Hypar. So their goal is to create a tool for regenerative design that doesn't require you to know code. And today you can go ahead and try if you know C#. So you can kind of see how far that got, but I'm not trying to, belittle their efforts. Definitely not. This is a ambitious and noble goal, but we're not there yet. Now, another example of this is TestFit. So this is a bit of a special case. So this tool does, it generates condo buildings, essentially, based on the parameters you feed it. And there are, I think, a couple of reasons this works. So one, this is a single building topology. So, and condos especially are much less complicated, if you think about it, than something like a hospital or an airport, right? That would be a much more complicated task to have this tool generate the relationships between rooms in a healthcare facility. But here it's just, separate the rooms, make sure they are fitting the layout. They need to be fire separated, sound separated, and that's pretty much it. And it just does a very quick study for you. But it's still a really great achievement, I think, to be able to. It's great that we have this tool right now, and I think examples like this will only be more present as technology progresses. So we're at the point where we have the hardware to do this, and but we don't have the software and the algorithms because they are way too complex. And unlike video games where you don't need to be just what you essentially need is that your character doesn't get stuck in the level and it can actually get out and maybe a few other parameters. But buildings are much more complex designs, of course. And actually, one thing I forgot to mention here is refinery. So refinery can run through iterations, but and it can give you metrics for performance, saying like this iteration has better performance in, let's say, daylight gains, but this one works better with the wind and such. The problem there is you have to sit down and code all these algorithms one by one for every single building you do, pretty much. So not very efficient. And data collection is becoming a big theme in the in every industry, I think, right now. And as I said, like, data is really valuable at this point, and it is so valuable that I had to kind of throw these cartoons here instead of actual data I have, because I didn't actually know what I can show here without getting myself into trouble. We keep creating these models that that are intelligent, that contain a lot of data, but it's questionable if we're actually using them to solve problems. And just to give a few examples, you could be like collecting model data to understand maybe the quality of your model. You could actually, and many companies actually do this. This year at Build, there were a lot of presentations about like how they use the model data and the company data in general, like holistically. And you can even associate your model data to your financial data, like looking at, okay, maybe when I do something this way, it causes me more hours, so maybe I should change my methods. You know, you can solve your financial problems, you can solve your model quality problems, and have a good oversight of your projects if you start harvesting data from your BIM models. Of course, the problem is there aren't a lot of tools to do that on the market right now. There are a few, but it also has to be kind of objective driven to be successful. Now, with all this, I'll unfortunately finish on a bit of a grim note here. So we're slowly adapting to these new technologies. We are implementing some of them. And it's progressing, but the big question, I guess, is big tech or a startup one day come in and start taking business away from us? So everything that big tech has got into, right now, just look at how retail is doing, not very well. And if you look at how taxi drivers are doing against Uber, it's definitely a losing battle. Like, nobody wants to take taxis. I mean, I'm not saying we're taxi drivers. Like, historically, it's just there's, because they're a monopoly and everything, they've been also not treating the customers very well, maybe. But at the end of the day, you don't want to be the taxi driver against Uber because you're going to lose. So either we adopt and develop and embrace these technologies, or we basically are maybe doomed to be removed from the market by either one of these like big tech companies, or like now, Google is now developing an entire neighborhood in Toronto for like just right under my nose, and that is a bit of a scary thought, because if they are able to succeed in their goals of creating more affordable, more sustainable buildings, like them being in this business for like 5-10 years, they achieve that, and we cannot, then we're fighting a losing battle.